Hi, and welcome to this tutorial on lesson 2.4. Earlier, we've been finding the zeros of a given function, but now we're going to kind of look at that in reverse. In this case, we're given the zeros, and we're going to have to find a function that will match those zeros. And really, there's an infinite number of functions that'll do that. So the first thing we're going to want to do is look at the zeros we're given and define our function as we'll call it f of x, and we have to multiply it by a constant, and this constant can, like I said, be an infinite possibility, has infinite possibilities, but for our case we're just going to keep it simple and use 1 for our a that we're going to multiply the function by. The next thing you're going to want to do is take each 0 and subtract x from it as a factor. So since -1 is a 0, that means that x minus -1 can be a factor of our function. And the same with 2. X minus 2 can be a factor. And finally, x minus the complex number 2 minus I can be a factor of our function. Now, the catch here is that they want real coefficients in standard form. And if we solve this function as it is, then we're going to get an imaginary number here. So a trick to avoid that is we're going to multiply by the conjugate, because if 2 minus I is a 0, then that means 2 plus I is also a 0. So when this happens, we're just going to have x minus the conjugate of 2 minus I, which is 2 plus I. And now notice, once I eventually multiply the two i's together, I'm going to get I squared, which we can simplify to -1. So, like I said, we're going to use a as 1 to make our lives easy, but that could be any number, really, and give us the right answer. And then let's just make this x plus 1, x minus 2, and let's simplify these a little bit. Since this is x minus 2 minus I, we'll make it x minus 2 plus I. And then over here we'll have x minus 2 minus I. All right, now we've got a lot of multiplication of binomials and trinomials going on here. So what I'm going to do is I'm going to FOIL these two, and then I'm essentially going to distribute these two. And then we'll get a couple parentheses in the end. So f of x, we can kind of ignore that 1 since the whole function will be the same. And we'll FOIL the x plus 1 and the x minus 2. So x times x is x squared. X times -2 would be minus 2x. 1 times x would give me plus x. And my last term's 1 times -2 is going to give me minus 2. Now the second two parentheses are going to be a little bit more difficult because we have to multiply every term in this parenthesis by every term in the second parenthesis. So x times x gives me x squared. X times -2 is -2x. And then x times -I is minus ix. So now with the 2, -2 times x is minus 2x. -2 times -2 is plus 4. And then -2 times -I is plus 2i. Finally, the I, we have I times x, which is ix. I times -2, which is minus 2i. And I times -I, which is -I squared. Let's simplify this a little bit. So we have x squared minus 2x plus x, which is going to leave us with x squared minus x and then minus 2. And then in the second parenthesis, the x squared doesn't have any like terms. We have -2x and -2x, which is going to give me -4x. The negative ix will cancel out with the positive ix. And then we're left with a 4 here, because the 2i and the negative 2i cancel out, and we've got negative I squared. This can be rewritten as x squared minus x minus 2 times x squared minus 4x. So plus 4 minus I squared would essentially be plus 4 minus negative 1. So that would be plus 4 plus 1, and that's going to give us 5. So finally, we have to do that crazy multiplication one more time. We have x squared times x squared, which would be x to the 4th, x squared times negative 4x, which is negative 4x cubed, and then x squared times 5, which is plus 5x squared. We've got negative x times x squared, which is negative x cubed. Negative x times negative 4x is plus 4x squared. Negative x times 5 is minus 5x. Finally, the negative 2. Negative 2 times x squared is minus 2x squared. Negative 2 times negative 4x is plus 8x. And negative 2 times 5 is minus 10. Let's combine our like terms, and we get x to the 4th. Let's see that. Negative 4x cubed and the negative x cubed give negative 5x cubed. The 5x squared and the 4x squared and the minus 2x squared together become plus 7x squared. The negative 5x and plus 8x will give me plus 3x, and the negative 10 stays negative 10, and we've just come up with a function that matches the given zeros and has all real coefficients, and that's the process you would use for this type of problem. So now here's one you can try on your own. See if you can use that method to come up with a function that matches those zeros. Notice that in this case you have the negative 2 with a multiplicity of 2, which means you're going to have two zeros occurring of negative 2. So you'll want essentially x plus 2 times x plus 2, and then throw in the rest of your zeros.